Hey guys, in this video I'm going to show you how to write your own blockchain in Rust. So here we are not going to use any third party or any SDK or anything like that. Let's do it. So I just call this hip zip chain and we are going to implement that in Rust. So the first thing we need to do, we need to bring up terminal. So we go to terminal, new terminal here, and then we use cargo. And then we use cargo new, and the name of project we call this hip zip chain. There we go. So now we have our project template. Okay, so now we go and update actually cargo tom and add our dependencies here. So I made that like that. All right, so here we actually included SHA-2, which actually includes SHA-256 hashing, is a secure hash. It's very prevalent for secure blockchains. We do have libp 2p for P2P network layer, and then we have Tokyo that is responsible for providing basically multi-thread runtime environment. We take advantage of the hex crate because we want to make our binary transaction in a hexadecimal to show that in more readable format, and we use log and the other basically dependencies. All right, now let us start to define our structure. So we need to go to src or source, and then we go to main Rust file here. Remove this default main function. We need to now specify our data structure for our blockchain. So we start with a simple structure, public one, struct, and let's call this app. And here we do have blocks, right? Public blocks, vector type. That's it. So that's our simplistic structure here. A derived attribute here for serialization, deserialization, etc. Then we define the block, how our block want to look like. So now we define our block to see how it needs to be look like, and I define public another struct, and this is our block. So here you can, for example, add different traits or whatever you like. So I just go with the simple one. You need an ID for sure, and the type of ID is going to be U64. And the other critical thing here is a hash. So hash is lengthy, so we use like string. The other one is, when you define a blockchain, it's a chain of block, right? So we have a block here, then we have another block, then we have another block. If you see my mouse cursor. So when you define this, it's like a kind of linked list, I would say, or tree, or binary tree sometimes, or Merkle tree. I mean, depends on the blockchain. But you need to have a chain. You need to make the chain. So how you can make the chain? You've got to hold the previous structure. All right, so now I'm going to define my own blockchain or the structure of my block and how it looks like. And here is the place you can add your trait and make a customized blockchain. Okay, so I go with the simple one. I call this block, and it's basically it represents one block of my blockchain. Okay, so here, what do I need? I need ID and type of that U64. This is like a unique key, I would say. And then I have another one. I call this hash. This is quite important, and since this is lengthy, I choose a string. I want to have it like a hex And the next thing is I want to make a chain. So guys, when you talk about blockchain, it means a block of a chain of blocks, right? You need to make a chain. If you see my cursor here, just imagine each of those are a block. So you need to somehow bind them together. Therefore, you need to have a pointer type of thing to the previous hash, to the previous block. All right. So you need to show, okay, what is the previous hash here. It's like a linked list sort of thing. I mean, as you know, if you study computer science, linked list is the is kind of building block for making different advanced data structures such as trees, Merkle tree, graph, and things like that. So now I need to define a previous hash. I call this previous hash, and type of that is also string. Then I need one important thing is timestamp. You got to be very careful about timestamp. Timestamp is something which is actually very important in blockchain, and it can be also manipulated in terms of security. Miners can manipulate that and perform like sandwich attacks and things like that. Depends on the logic of your DeFi project or your blockchain whatsoever. So I defined that I64. That should be enough for a Unix format of timestamp. And then I need the data. I want to put the data on that. I would call this data, and type of data would be string. And what else? I need the nouns. So I go with basically bare minimum. But of course, when you want to make a mighty blockchain, let's say you want to make a Solana killer or something like that, so here you can add more stuff. U64, and that's it. So now I have my block. Let's save the code. So hash here gonna be like a SHA-256 hash. It's lengthy, and that's why we use a string. And for previous hash the same. And here we do have Unix format, Unix timestamp format, data and nouns. So now let's get started by the implementation of our app structure. Okay, so I use imp and then app. Now I'm going to implement my app here, and I have function. Self here on my blocks, and select all. Okay, to go with this. Now I'm gonna define my basically genesis here. So now let's define genesis block. And if you don't know what is genesis block is the actually first block, root block. If you know about the tree, the root, the first node, or linked list, the first node. Okay, that's genesis in a nutshell. Genesis block, it's a block. With these attitudes. What is the idea of that? Is the first block. So the idea of that would be 0, right? And what is its timestamp? It's gonna be now, the time that we actually run this. Gonna be UTC, and now then we need to convert that to timestamp. Timestamp. Okay. Another trait here. Previous hash. So guess what? The previous hash is gonna be basically nothing or 0. So I define it in this way: string from Genesis and the next one is gonna be data string Genesis. So this is actually a hard-coded, block. So Genesis block is a hard-coded block, and it doesn't really, have valid kind of previous hash and this sort of thing. So but we specify that with ID 0. So we need to give it a nonce. So I would give a number, kind of random number. Let's say something like this, and need to give a hash here, and the hash of block is gonna be a random hash. So I'm gonna string. It's all good to go. And here, push this block. So now we push our Genesis block to our chain here. Okay, so this is how we can actually initialize our basically application here, or our chain, with an empty chain. Okay. So after this function, we need to add some other different functions. So let's say one of the other critical functionality of our blockchain is to be able to add new block to this chain, right? So let's define another cool function here. I would call this try add block. Okay, we need this reference and self, and then we've got to give the block. The type of that is type of block, right? So if you are not familiar with Rust, just when you define a variable in Rust, by default, in contrast to the other languages, is not, let's say, mutable. It's immutable, and this is because of the memory safety and the other stuff of ownership and memory safety of Rust. So in order to make it like a mutable variable, you need to define let. And define that beside of let, or what you define that by let. So one thing I think I just noticed that is nouns. To make a error handler here. So there is at least one block in our chain. That's what we expect. And then we say if everything is okay, then we are going to push this one. Blocks and push. So here we check if everything is okay and it's valid, then we push the block. Otherwise, we say something doesn't add up here, and what we can do, we can make like an reproduce an error here and put some message. We can't it's possibility and the block valid. So here we do have a function. We invoke that, but we don't have its implementation. So we need to go now define this is block valid, function. So we have two parameters with a reference to self. And we have block, type of that, reference of the block. And this block chase block. And here is the return type is boolean, is true or false. Okay, so I finished this function here. So regarding difficulty prefix, that actually specify the difficulty of the mining scheme. So here I'm gonna add basically the difficulty of the mining. Um, this is basically provides us a simple mining scheme for our blockchain, right? So I define this as constant, and the type of the name of that is difficulty prefix, and for that prefix, let's say start with 00, and str, and it's equal to, let's say, 00. All right, so what else we need here? So as you can see, after defining difficulty prefix, now we need to implement this function here, binary to hash representation, or hash to binary representation. So we define that globally, and we are getting ready for the mining part. So why we define that? Because we want to have the binary representation of the a hash, block hash, because here we define that as a string, but here we want to have its binary representation for the validation function. All right, so after defining this critical function to verify a block, now we need to verify the whole chain. We need to validate that as well. All right, so that was actually a piece of puzzle, and now we need another critical function here to validate the whole chain. Is chain valid, and so here we define the whole chain valid function. So what do we do here? We here we the ID 0 belongs to the Genesis block, right? So we ignore that because that's our hard-coded block, and then we go through essentially all existing blocks after the Genesis block and invoke is block valid function to verify the whole chain. So as you can see, by defining kind of primitive functions, it makes the whole thing easier. So now we can actually proceed even faster. So now there is one more function left before we plunge into the mining section, and now it's time for consensus. So of course, for this video, I consider a simple, quite minimalistic consensus here. And when we want to choose a chain, what is our criteria? I mean, in normal life, there are so many parameters and factors involving, but for our practice here, so when we want to choose a chain, we simply go with the longest one. That's our consensus here. That's what we. So now we call this one function choose chain, right? Okay. All right. So finish our choose chain function. So here we check the make sure our local node is valid or not. Then we check the remote node whether is valid or not. And if both are valid, then length of that matters the most. So if the length of local is more, we go with that. Otherwise, we go with remote. So here the as the longer chain is better for us. So that's our simple consensus. All right, so we are done with the basic functions of our blockchain, and now we need to go and think about the mining part. So I stop the video here and I create a new video, and in that video I explain you how to implement the mining functions.